Welcome back. So last lesson we saw how you can analyze the requirements for a database using an entity relationship diagram, and in this lesson we'll look at how we can adapt our database to represent the links between the tables that represent the different entities. So in this lesson we'll see how to build a relational database with links between tables. This is done by using keys, key fields. We'll look at the advantages of using a relational database over a flat file and the importance of preserving the integrity of the data. So you might recognize this diagram. It's an entity relationship diagram. This is our first stage when we're setting up a database. We think about what entities there are and what the relationships between the entities are, and the links between the tables are shown as these lines, and the three lines at the end show that there's a one-to-many relationship. One customer will place many orders, but each order only talks about one customer. Now, how do we make these links work? What we do is we take the primary key from one table and put it as a column into another table, and that will link the tables. We use the primary key because remember that will uniquely identify, for example, the customer, and the customer won't get mixed up with any other customer. This means that we don't, if the customer's making an order, we don't need to put the customer's name and address into the order form. We just enter the customer code, and if the computer needs the customer's name and address, for example, to print out address labels, it can look that up using the primary key. So the primary key is the unique code that identifies each entity. For example, it will identify exactly what customer has placed the order, and the primary key for the printer table will identify what printer that customer has ordered. These primary keys can be copied into other tables. For instance, the customer key can be copied into the order table. When it's copied across like this, it's called a foreign key. This is the only example of repetition that you should find in a relational database. Sometimes as well in a database we use secondary keys that can help you find the record that you want. I'll give you an example. If a customer phones my business and I want to look up their orders, I'll probably look up using their surname rather than their customer code, because probably we don't even remember their customer code unless we look it up. So, do I copy the customer code into the order form or the order code into the customer record? It's easy to answer this question. We look at the one-to-many relationship and we copy the code from the one to the many. One to many. This is why it was so important for us to work out all our one-to-many relationships before we started creating the relational database. So the answer is we would copy the customer code into the order record, not the other way around. So our order form could actually be very simple. It could include probably the date that you placed the order, the customer's code, just their code is enough to identify them, the product code, we don't need any other details of the product, the number of items that we're going to buy, and the total cost, which we can work out. And that means our order form is extremely simple. There's very little repetition or replication, but it's got all the key facts that we need. Okay, so building on this, if you're my student, look at question 6 in the relational database workbook to continue with this task. Okay, bye for now. Let's briefly think about how that would work in practice with a company that sends orders to customers like Amazon or any of the other online retailers. The order would include the customer code and the product code, these allow us to get all the details that we need from the other tables, and that makes sure that we can send the right product to the right person. Remember that the primary key uniquely identifies just one customer. To make our life a bit easier, databases often include extra tables called indexes. We don't look at those directly, but they are sorted in order, so they remember the order of the tables, sorted by particular fields, for instance the customer's surname, and this will greatly speed up the process of searching for the data we want. I'd like you to cast your mind back to when we did binary and linear search. If a binary search is much faster, but it will only work on a sorted list. So an index is a way of remembering the sort order of one of the tables of our database. The disadvantage is that creating indexes uses up space and takes some extra processing, but the advantage is our searches are much quicker. So just a reminder, in a relational database, one of the most important features of a relational database is that the facts are separated into different tables and each fact is stored only once. Many students say the advantage of this is that it takes up less storage space, but actually storage space isn't really the most important limiting factor. The real reason this is good is it's less work for us, for the people who work in a company. They're not having to type in data or update data all the time. And because every fact is stored once only, there's much less chance of an error occurring. An important issue which arises here is referential integrity. This is because each table has got links to other tables, references. So for instance, the order form has got the customer code, which is a reference to the customer table. Now, if you delete a record, for instance, you accidentally or on purpose delete a customer record, that link will now lead nowhere. And I've written deleting is not allowed. That's a bit strong, but deleting is generally avoided in a relational database as long as there are any links to the data. We tend not to delete it. So if you've done all of this, watch this lesson. If you're my student, part 2 of the relational database workbook will cover all of these points. So have a go at that and we'll continue in the next lesson. So bye for now.